Welcome to Climate State, a weekly to bi-weekly broadcast on what's going on with the Earth's climate systems. This is your host, Gerard Spring, coming to you from the north. So in this one, I want to take a look at what's going on up in Greenland, and in particular, I want to try to connect some of the large temperature anomalies that we've seen up in the Arctic and the high Arctic this past year with ice loss in Greenland, as well as ocean currents and ocean temperature anomalies that we're seeing off the eastern coast of North America. I'm going to start this one off by looking at a phys.org article that was published on May 26, 2017. And this one is called NASA Discovers a New Mode of Ice Loss in Greenland. A new NASA study finds that during Greenland's hottest summers on record, 2010 and 2012, the ice in Rink Glacier on the island's west coast just didn't melt faster than usual. It slid through the glacier's interior in a gigantic wave, like a warmed freezer pop sliding out of its plastic bag. The wave persisted for 4 months, with ice from upstream continuing to move down to replace the missing mass for at least 4 more months. This long pulse of mass loss, called a solitary wave, is a new discovery that may indicate an increase in the potential for sustained ice loss in Greenland as the climate continues to warm, with implications for future rates of sea level rise. The study by 3 scientists from NASA's Jet Propulsion Laboratory in Pasadena was the first to precisely track a glacier's loss of mass from melting ice due to the horizontal motion of a GPS sensor. They used data from a single sensor in Greenland's GPS network, sited on bedrock next to Rink Glacier. Rink is one of Greenland's major outlets in the ocean, draining about 11 billion tons of ice per year in the early 2000s, roughly the weight of 30,000 Empire State Buildings. In the intensely hot summer of 2012, however, it lost an additional 6.7 gigatons of mass in the form of a solitary wave. Previously observed melting processes can't explain that much mass loss. So what's going on here is that the glaciers in Greenland are beginning to show different methods of ice mass loss, which are due to large amounts of meltwater pulsing through underneath the glacier. And what's happening is the meltwater is passing down through the glacier and hitting the bedrock and flowing underneath the glacier. And this is lubricating the glacier, allowing it to slide and calve off much faster than it ordinarily would. So there are a lot of changes that have been happening up in the Arctic region, in particular the Arctic sea ice, as well as what's going on with the Greenland ice dome. And these changes are, of course, due to a large amount of heat being transported in the Arctic in the form of both warm water coming up via the Gulf Stream, as well as pulses of warm air coming up due to destabilization of the jet stream and air currents. So in order to track some of these changes that have been happening up in the Arctic over the course of the past year, 2017, I've put together a time series for you guys using plots from Climate Reanalyzer. On the left-hand side, you can see the temperature for the high Arctic, while on the right-hand side, you can see the corresponding temperature anomaly or difference from normal. And as the year goes on, what we tend to see is that during the late autumn or early winter, a lot of large temperature anomalies begin to develop over the high Arctic, the Arctic Mediterranean, as well as the Greenland ice dome. So a lot of warm air is being transported into the Arctic, and this, of course, corresponds to destabilizations in stratospheric air currents such as the jet stream. Additionally, we also have a lot of heat being transported into the high Arctic via ocean currents, and this could also be driving warmer air temperatures as well as destabilizations in the jet stream. These warmer temperatures over the Greenland ice dome can cause 2 main effects. On the one hand, we have the potential for more convection, which would lead to snowstorms, which could potentially lead to a gain of mass in terms of the Greenland ice sheet itself. However, there's a lot of heat being transported into the Arctic, and this will translate into longer melt seasons, which will contribute to a larger mass loss or mass wasting of the Greenland ice sheet. And when you combine these 2 effects in the long run, what you end up with is a net mass loss of the Greenland ice sheet. It's important to note that the overall dynamics of what's going on up on the ice sheet are a lot more complicated than this, and there's a lot of subtleties that need to be taken into account to figure out exactly what's happening. However, this basic approach does give us a pretty good idea of what's going on up on the ice dome. So I want to take some moments to try to connect what's going on with meltwater coming off the Greenland ice dome and to try to show how this affects ocean currents and ocean temperatures, particularly along the east coast of the North American continent. So I've zoomed in here on Earth Null School on the south tip of Greenland, as well as the Labrador coast here and Baffin Island here. And in particular, I'm interested in this region, which is called the Davis Strait, where you have this slightly warm pool interacting with its cold flow coming down from the Greenland ice dome. And if we take a look at the sea surface temperature, we can see that a lot of this water is very close to the freezing temperature of salt water, which indicates that this is very likely meltwater which is coming off the Greenland ice dome. If we swing back and take a look at the sea surface temperature anomaly, we can see that this water is about 3 degrees colder than average, which would indicate that we have more meltwater coming off the Greenland ice dome than usual. A lot of these fjords here on the west coast of Greenland are very sensitive and have been experiencing longer melt seasons than usual, which is what is causing this temperature anomaly here in the off the coast of Labrador. If we zoom in here, we can take a better look at what's going on with some of these ocean currents and follow them down and see what happens to them. So here we can see the meltwater coming down off the tip of Greenland and flowing along the Labrador coast here. It continues southward and passes Newfoundland Island here. And just south of Newfoundland Island, we have a junction of cold water, minus 4.4 degrees Celsius colder than normal, with the very warm water flowing up from the Gulf Stream. And this is driving a lot of very turbulent ocean activity here. So these currents between these cold and warm water, where there's mixing between these two water pools, you have a lot of strange anomalous current behavior. And what's happening is the fresh water, which is coming off the Greenland ice dome, is less dense than the salt water, which is coming up from the Caribbean via the Gulf Stream. And we can see we have actually very large temperature gradients here. For example, here on this boundary, we have 3.8 degrees warmer than normal, whereas just to the east, we have minus 1.7 degrees colder than normal. So I also think it's useful to step backwards in time and take a look at what happens to the time evolution of this cold water pool. So here we are on May 29th, 2017, and I'm going to step back 5 days by 5 days and take a look at the temperature anomaly and see if we can interpret anything from the changes. So here we are on May 29th. I'm going to step back 5 days on May 24th. We still have a lot of mixing, a lot of turbulence here with the Gulf Stream. Stepping back 5 more days, the 19th of May, we also have this cold water pool is still very well formed. Stepping back 5 more days, we have actually the development of very cold area, 5.6 degrees colder than average, while right here off the coast of Nova Scotia, we have 8.4 degrees warmer than average. Huge temperature anomalies showing up on May 14th. Stepping back 5 more days, we still have that this cold water pool is well formed. Stepping back 5 more days on May 4th, we can see that this is a bit less well formed. And then if we step back 5 more days on April 29th, we can see that this cold temperature anomaly is actually gone. And what we have here is the warm water temperature anomaly that we've been seeing pretty much throughout the entire spring season off of the eastern coast of North America here. However, if we zoom in up here on the coast of Labrador, we can see that this meltwater pool is just beginning to form, and we have minus 3.0 degrees colder than average here, indicating that we have the melt season for Greenland starting a few weeks earlier than normal. So it's important to remember that what's going on up on the Greenland ice dome really affects all of us, and the Greenland ice dome is one of our most important barometers and metrics for what's going on with Earth's climate systems. The Greenland ice dome, in addition to all of the other great cryosphere reserves, is one of the major stabilizing features of the Earth's climate systems. And if we lose the ice sheets, then we lose the possibility of life on Earth as we know it. It really is critical that we act now to try to raise awareness to this issue, as well as to try to preserve and protect the great ice sheets of the North. So if you enjoyed this one, please hit that like button and subscribe. And I'm looking forward to having you along in the next one.